Those stairs, as someone who did that as well, that was quite the chore. So today's talk is about building resilient integrations. First, I'd like to introduce myself. My name is Dave Moore. I'm the Director of Software Services at 8thLight for the Los Angeles branch. So we have 4 branches now, one in London, one in Los Angeles, one in Chicago, and one in New York. And we started the Los Angeles branch about a year and a half ago. It's been a huge learning experience, just building a core group of people to, what 8thLight is all about, to give you an idea, is, building software with a craftsmanship approach, right? So the software that we build is, we take our time, do it the right way the first time, just ensure that we're delivering high quality software to the clients that we have, right? And building a team around that has been extremely rewarding. You get to meet a lot of people like yourselves who are very passionate about software. There's a lot of people going to conferences, reading books, giving presentations, exploring kind of different things about how to write software in different ways and various approaches. And it's exciting to be part of that team. But yeah, so that's a bit about myself and 8thLight. Now, building resilient integrations. Let's introduce this topic. So for a long time, to be productive in your job, you want to leverage existing code. This goes back to object-oriented, design principles and probably even a little bit further before that. But nowadays, a lot of that is around integrating with third-party services. Sometimes the third-party service is actually a different team in the same organization. Sometimes it's a different company. But as we kind of see this, evolving landscape, moving towards these distributed systems, a lot of what we do today is gluing these things together. And when things fail, less and less they're failing because of code that we wrote for business logic, but typically it's failing because the third-party integration is acting in a way that you wouldn't expect. And so we're going to explore that a little bit here, and that kind of introduces things. So you may have noticed that we have a 2-hour slot, which is pretty massive. We have a bit of a talk and then a workshop, and then another kind of continuation of the talk shortly thereafter. So the goal is to introduce the concepts of building software, with this approach of resiliency, right? Then apply them, give a shot at applying them, and then also talk about the lessons learned from when we did apply that, right? So I want to do a quick poll here. Who brought their laptop with them? Raise your hand. Yes, awesome. Okay, this is going to work. Perfect. I made a backup plan where I was going to do some live coding, but that's scary, so I'm going to make you guys code. Yeah, for the workshop portion, that's when we will do that, right? So just to give you a brief introduction of what that's going to be, I built an API and deployed it to Heroku, and it is intentionally a piece of crap, right? It's going to fail randomly in ways that I've been burned before. And so when I was coding this thing, I was like, yeah, these guys are gonna, So, but ultimately the goal is you guys are gonna be programming an HTTP client that has to use some of the concepts that we talked about in order to actually run. So that's gonna be fun. Yeah, so there we go. So right, so introduce the concepts, workshop to apply the concepts, and then a brief discussion afterwards to internalize the concepts. So the goal is by the end of this 2-hour slot, if you stick around for the whole thing, you will all walk away having gained something from this. So that's the goal. So let's talk about this, right? High availability is a user expectation nowadays, right? So we're talking about, you have your credit card, right? I myself, from Los Angeles, I don't have euros because I forgot. If the software, when I'm using my credit card to process my meal, goes down, I look like a total jerk because I have no recourse to pay them, right? And so that's pretty important, right? Basically, there's a lot of these types of examples where users depend on software now more than ever. And another example is when I was flying over here, I flew on a plane, right? That plane had software that communicated with external, probably the tower, right? And the tower, if they're doing their job properly, depends on software that makes sure that planes aren't crashing into each other. I'm here in one piece, thankfully, so at least the industry as a whole is doing this right to some extent. But if you've dealt with software before, you've ultimately dealt with failure, right? One final example is another important piece of functionality is, if my software goes bad on my Tamagotchi is going to starve. That's terrible. We can't have that. So the only problem with that expectation is that failure is everywhere. So please raise your hand if you've dealt with some sort of unsuspecting software failure. Right? So that's a whole lot of hands. It was mostly a rhetorical question because I knew the answer to that, right? I'm giving this talk because of that, right? Failure is everywhere. It's something that we have to deal with, and it's very difficult to kind of figure out the various ways in which these things can fail. So why is it that failure is everywhere? Is it the fact that we've got a huge demand for custom software, which then, as a result, gave us a supply problem with qualified engineers? I would argue that that's some piece of the pie, but that's not what we're here to talk about. Is it instead that we build software with other buggy software, aka our tools? How many people have been writing code, and I use Sublime, and you install a package that is supposed to automatically format something, and then you hit save, and then the lines go all the way over here, and you're like, what the heck, So it's kind of profound to think about that, right? Our job is to build software that works and doesn't fail, and yet we're using software that doesn't work and does fail in order to make this software that does work. It's weird. It's strange, right? So that is also another problem, but not the topic in which we're here to talk about. Deadline pressure. Who's dealt with deadline pressure before, right? Another rhetorical question. It is permeating throughout, our industry, right? The whole reason we exist is to solve business problems, right? We build solutions to those business problems. As a result, there's other parts of the business, like marketing needs to say, hey, it's going to be out at some time. We can't take 12 years, to make this thing because someone else will have solved it by that time, right? That's just the forces of the marketplace. So, but that deadline pressure is very interesting. We're going to dive into that towards the end here, but just to touch on it, we have to make sure that we're not taking that pressure and letting it affect us to where we do our jobs, where it's at the point where it's unprofessional, right? There are plenty of people who have deployed software, aka the company that rolled out the original US healthcare plan and failed miserably, right? Though that type of thing is problematic. You can't ship something that doesn't work. It doesn't solve the problem, right? So you have to keep that in mind when dealing with deadline pressure. More on that later. Another reason why failure is everywhere is we've got endless amounts of possible failure points, right? The systems in which we work in by themselves are inherently complicated, right? Building a Hello World application that stores its state in memory is a whole lot easier, assuming that Hello World had state. Some example that has state. We'll say a game, Mastermind game, right? Mastermind game has state. If you're storing the state of the Mastermind board in memory, it's a whole lot easier than it would be if that state is stored in an external service, right? So various reasons for that. Here's a quote from Jeff Hodges. Jeff has talked about building software in distributed systems at length. He also wrote a blog post, forgetting the exact name of it. It's something about distributed programming for young bloods. I don't know if you guys have read that before. But yeah, he talks about, the difficulties in these sort of situations, like switches go down. You've got a slow disk drive, somewhere could, if you're depending on it in the wrong way, slow down the entire request response flow, So that would be unfortunate, right? So let's take an example. GitHub. If they had a service that stored your profile image, right? And in order to return the HTML to render the page, when you go to your homepage on GitHub, if it waited to get for that service to return with your image, and that service was taking a long time, it would slow down the entire process, right? To the point where users would be like, forget this, like, I'm going somewhere else. Fortunately, they're smarter than that, and they haven't done that sort of thing. So a lot of these types of things are done with subsequent calls with AJAX, right? So it doesn't slow down the entire request. But those type of things are, important to think about. So it says, worked fine in dev, ops problem now. I like this picture because she is suspiciously evil. Right, and so just because it works on your laptop doesn't mean that when this thing's out in the wild that it's just going to work in production, right? There's a whole lot of other factors that you have to take into consideration before you call something done. And it's our responsibility to account for external failures, right? If you were this developer, you could say, oh, well, it's not my fault. This third party's acting up. Just go yell at them until they fix it, right? And you could do that. And in fact, I think I would argue that most of our industry does that, which is really unfortunate because there are ways around, architecting your system to where it assumes failure is going to happen. And I think that's what we need to do. It's a fundamental shift in the way that you write code. If you are ever integrating with a third-party system, you need to make that assumption. And if you're not, you're going to get burned and you're going to end up in a situation like this. Hopefully you don't respond in the same way as this girl did. So ultimately you can't trust third-party integrations. We can't assume 100% uptime. We want to make sure, so I talked a little bit about we want to design for failure, right? But what does that look like exactly? Can anyone give an example? Say that one more time. Amazon's down. Okay, so Amazon goes down, so how do you deal with that, right? Some people would would host in two various places and then put some sort of load balancer between the two. That's one way to do it. That's more of an ops type thing. If we're talking about a code-specific thing, one of them that comes to mind is wrapping your dependencies, right? So let's take a sample application. Let's stick with the mastermind game, right? The state of the board is stored in an external service. Let's say that there's a comparable external service somewhere else, right? We want to build our software to the point where we can swap out if we say, oh my God, this service fails, like its uptime percentage is like 80%, and we need 99.999% uptime, right? Our users demand it. Otherwise, they're going to go to service B, right? We want to make sure that we've built our code in the way that swapping out that dependency is as simple as changing one file, right? And so a lot of times I see this when I come across code. And to put this in perspective, 8th Flight is a consultancy, so I've seen a lot of different code bases. And what I see more often than not is when someone's making a integration, third-party integration, or even using a third-party library for that matter, they take the interface that's given to them and they say, okay, this is the interface we're going to go with, right? everywhere in the code that deals with anything related to this is going to have to talk using this interface, right? But there's a problem in that, which is if you find out that that's a crappy integration point, crappy third-party service, just swap it out. You're going to have to change it everywhere in your code base. Now, if instead you wrapped your dependency with your own interface, and by the way, your own interface could be the exact same interface, right? The thing that we're trying to do is the actual code is linking with your code, right? Not someone else's code. And so if you needed to swap something out, you could swap it out under the hood. The rest of the code would act under the same interface that you defined, and you'd be good to go. Right now, a lot of people think, well, why would you do that if it's the exact same interface? Like, that's pointless, right? And my argument to that is it's not pointless, right? The moment you need to switch out is the moment you go, oh, crud, like I may have to rethink kind of how this is working. But if you've already thought ahead of time, then you don't have to change a line of code except for the code inside this, this wrapper that you've built. So that's one way to do it, right? You also need to build in ways to gracefully fail because you can't trust third-party integrations, right? So in the example of GitHub not, you're not returning back the avatar, you still want to be able to create a pull request, right? Because it's your job to create a pull request, and now's the time, the code's ready, you're good to go, but the dang avatar service is down, right? You want the page to show up, maybe with a degraded version, like a silhouette of a face or something, right? That's another way to kind of say, okay, I as a developer, when designing this system, know that I'm integrating with this external service. If this external service fails, I have a backup plan. This is my backup plan, right? Those sort of things, if you haven't thought those through, are going to make for an extremely poor user experience, and additionally, sometimes even worse, the thing won't work half the time, right? So that's trouble. So most of this talk is about how we as clients can deal with third-party integrations, but I do want to touch on this, which is from the third-party services perspective, right? They do have some protection. There's enough information about like protecting your like making your service highly available. There's enough of that information out there that this could be an entirely different talk. But I did want to just touch on the points that it's worth noting that if you use replication plus automatic failover, then that is a recipe for higher availability, right? So you could think of this at many different levels, right? For the ops level, let's say some component of Amazon went down, like your RDS East went down, right? You want to be able to automatically fail over to RDS West or some other place where data is stored. And in order to automatically fail over, you need to have replicated that data. Same thing goes for a load balancer, right? You've got load balancer is something that distributes traffic between various nodes. If you're thinking about this in the client-server example, that's where the behind the load balancer is some number of different servers that are running your application. If one of those servers goes down, it's just a matter of deregistering from the load balancer and then having those other two, right? So there are things that third-party services can do, but as we saw when we all raised our hand, we know that not everyone's doing this. And even still, if someone's doing this, it does not guarantee uptime for everything, right? 100% uptime if you're traveling across the wire, across the internet, is just not guaranteed. So even if they have these protections in place, we still have to go at it with this failure lens, so to speak. If you're interested in, first off, if you're confused by anything I said and you want to learn more about this sort of stuff, come up to me after the talk and we can discuss that in length here. But we're going to move on for the time being. So this next section is going to describe things that in my career I've been burned by. and I'm going to see if you guys have been burned by the same things. Okay, I assume that you guys have been burned by this. Mismatch between documentation and actual API. So yeah, this is pretty self-explanatory, but basically you can never trust documentation. Why can you never trust documentation? That's an interesting question, right? So when you're writing code, the same thing kind of goes with comments, right? When you're writing code and you comment on something, and then you commit it, and then things change throughout time, and then you come back to it and you read the comment, how can you be sure that that comment's true, right? Commenting is a form of documentation. You can't, because the compiler doesn't enforce it, right? Same thing with third-party services. You can write this nice documentation, but if you're not diligent, then it's going to go out of date and it could potentially lie to you, right? Now, obviously, people don't want to write documentation that is a mismatch between what it's telling you and what the actual API is. But there's nothing that forces that to be true, right? When you make a syntax error, the developer gets feedback. Oh, forgot a semicolon. Oh, forgot a parenthesis. Oh, over here. And they can't progress until that issue's been remedied. With documentation, you just don't get that, right? Because there's nothing that's verifying that this is true, which is why almost in all cases, you want to instead depend on tests, right? How many people use test-driven development? How many people raise their hand but don't actually do test-driven development but do tests after development? Sometimes, yeah. It's okay, all right. So that's a whole different talk as well. But any sort of tests, right? If they pass, they're part of a continuous integration build, whatever, right? When you check them in, something's running them, something's verifying that what you've written here is true. So if you're reading a test, you know for a fact it's true because it's actually being run and it's being executed, and it has that compiler verification, right? Compiler or runtime verification. So you don't always get this luxury, right? When you're dealing with a third-party service, it's not always open source, right? And that can be problematic sometimes. If you do have that, whew, holy grail, integrate with that service, right? Like this is a good start, right? Those people are doing it right. It really gives you a fuller understanding of how things work and gives you, the ability to dig in when things aren't working the right way. And a better understanding because you can go through that test. Say you don't have those tests. They're not open source, or if they are open source, they didn't test anything. How can you verify that the actual API is doing what it says it's doing without just, pushing to prod and crossing your fingers and watching the building burn down, right? Something we don't want to do, something I don't advise. You can build tests yourself that hit this API, and you can put it as a part of your continuous integration build, right? A lot of people use mocks for when they're integrating with a third-party service. I do as well. I do that for when I'm because when I'm programming on my laptop and I want to run the tests, I'm not always going to have access to Wi-Fi. I don't want my tests to depend on a internet connection, because then I might be out of luck, right? Anyways. But in certain environments, I need this safety. I need to make sure that the mocks that I was using, those fixtures, actually represent the truth, right? So there are ways to generate those fixtures by actually hitting the service. There's various libraries that can do this, and you can generate the fixtures for your local machine, and then when you're running the tests in continuous integration, they can hit the actual service, right? That way, if you're making a change and you think you're using an endpoint that you hadn't used before, or using it in a different part of the code base in a different way than you had previously, you can be sure that when this thing goes live, that's going to be the way that the actual API depends, or the actual API works, right? So being able to swap out the HTTP client layer, so to speak, will accomplish this. And that kind of goes back to wrapping your third-party dependencies, right? Wrapping your third-party libraries would be how this is accomplished, right? You wrap your HTTP client, and then, you know, when you're running your tests, you'd be able to swap in whatever you want to. It could be a mock HTTP client. It could be one that goes to their sandbox environment. It could be the production one, right? Those sort of things are important ways, or good ways to kind of solve this problem. Schema of response changes based on API state. So I've dealt with this before. That is when, say you've got a GET request, and it returns widgets. And then you've got a POST request, where you create a widget. And then you hit that GET request widget thing again, and instead it returns doodads, right? Because there's widgets in the system now. You know, that sort of thing is pretty frustrating. And what you want to make sure is, you know, like schema of response, right? So schema of response, so that's where instead of having widgets, actually let's go back on this. You post to widgets, you get back widgets, and there's all those widgets there. You make a post to doodads, and then when you do the get widgets, the doodads is there now too, right? Something that you didn't expect before. And it changed based on what's there and what's not there, right? So what you want to make sure here is that you defensively deserialize your JSON or XML or however, whatever thing you're using to talk to this thing, because there are some, like if you're in the Java world, what is it that? Jackson parser, right? You build a Java library, or not a Java class that has getters and setters based off of what the JSON is going to look like. And if something's not there, it's going to actually break, right? That's one example. There's other examples from other languages as well. But you need to make sure that you tag, hey, this may not be here, you know, based on these, you know, the situations that the API, the external situations, right? The state of the API. So the lesson here is be very defensive when taking any of that information in, right? Release an update of the API that breaks the original contract. Oh man, this would stink, right? This goes back to the lesson learned here, right, is going back to making sure that you're wrapping your dependencies here, or your integration point, right? Because if they release an update and they say, hey, this is a collection now, this is an array, and it was an object before, and you go, oh, I got to change that in like 20 places, right? That's what you're trying to avoid, right? So if you set your own interface, then it is what it is there. So you want to update one file instead of 100 or potentially 1,000, depending on how big your code base is. Been burned by latency before. One thing to consider here is timeouts, right? We've used timeouts before. Timeouts are a really good thing. However, what happens if you're making, you know, say we're talking REST here, right? You send a post request to something. It's in the process of making that resource. Then it takes a long time, so you time out. What do? Do you send another post? Because then you're making two resources, right? That could be tricky. You want to favor APIs that have built-in idempotency. So an idempotent API is one where if you send something, for example, a post request, right, to create something, and then you send the same request again, you replay that request, it's going to first look at its system and be like, has this already happened? And if it has already happened, just do nothing and say, yeah, you did it, good job, right? And so that's where, you know, you don't have to worry about that sort of thing, right? And when you're shopping around for the different, you know, third-party integrations that you have, you want to favor those type of endpoints, because it's a lot easier when it comes down to, when failure happens, how do you handle it, right? If it wasn't idempotent, what would you have to do? It fails on the post, right? You'd have to send a GET request and look for it and hope that that doesn't time out, right? And if it doesn't return something, you say the request comes through successfully, and it says, nope, we're all good, then you resend it, right? There's a lot of different steps there, and it'd be a whole lot easier if you didn't have to go through that process. But it is important that you go through that process if idempotency isn't built in, because there will be situations where you do have to time out because latency will occur. And if you are not going to that level of handling failure, then your application is going to have expectations of the API, of the third-party service, that are false, right? Because you, in your head, when you're coding this thing, have to keep in the context of what the state of the API is, right? And if there's a mismatch between what the client expects and what is actually the state in the real API, that's where some of those problems start to bubble up. And that's a really easy one to get fooled by. Another thing to consider with latency. Say you're just making a GET request, right? A lot easier. You're not changing any state on this API. Something happens, latency happens when you send your first GET request, and what do? You time out. Then what do? You retry, right? So let's say you take that approach. You retry, say that times out. You retry again, that times out. You retry again, hoping that it doesn't time out. It times out. You retry again, and you've effectively DDoSed that third-party service, right? You've brought them to their knees by sending so many requests they can't handle it. So when that third-party service deals with any increment of latency where people are starting to time out, the requests that come in skyrocket using this approach, right? So that's a pretty scary situation to be in. This is especially bad if this third-party API is actually just a different team within your organization. They're not going to be excited that that happened, right? Especially because that could have big impact, not just for you, but for other teams that didn't make that mistake. So the last thing you want is someone coming to your desk and going like, hey, what are you doing that for? Like, you totally screwed us. So what's a way that you can not do that, but still build in some sort of resiliency to your client, right? So there's a concept called back off retry strategy. And so that's where you make a request. If it times out, then you say, okay, give it a second, make another request. If that times out, then you say, okay, give me I'm going to wait 2 times as long. So give me 2 seconds now. I'm going to wait, and then I'm going to make another request. It times out. Say, okay, give me 4 seconds, and then 8 seconds, and 16, and up to a number where I can't do math, right? Like, it just keeps doubling, right? And so you're waiting and waiting and waiting, and eventually it gets to a point where you're like, okay, this thing's not coming up. I'm just going to log this, and hopefully someone's listening to the log, or some system, not someone, and sends a text message alert like, hey, something's broken, right? This way, because imagine that's happening from your users' browsers, right? You could potentially have, however many users are currently using the system, that many requests happening every second if you're not doing this, or worse, every millisecond or whatever, right? But if they're doing that back-off strategy, then they're going to be sending a whole lot less requests. When it first happens, they're going to be just double-checking in smaller intervals. But as it is happening with a large frequency, you can make the assumption, okay, if it didn't work 8 seconds ago, it probably won't work right now as well, right? And so you can kind of not bring down the system with requests, which is a good thing. This happened. So I was hitting an API, and randomly, the second half of my JSON payload was missing. Just randomly. Like, That sucked. It's as if someone was doing substring, and they're like, you know what? Every once in a while, I just want to substring this random thing, right? And so what do you do in this situation, right? What did I do in this situation? I'm not saying this was the right thing to do. I'm not actually sure what the right thing to do was, but I ditched it. I was like, all right, this is garbage. Get out of here. And I wrapped this integration point, so it was easy to swap something out. Yes. All right. So we've got laptops. Now I'm going to ask another question. So raise your hand if you not only have a laptop, but you are comfortable from scratch coding a basic HTTP client in whatever your favorite language is. Hold them high. Stay there. OK, keep holding them. Keep holding them. OK, so for the people that are not raising their hand, look around, find someone that's raising their hand, and buddy up with that person, right? Because the goal here is to build something, and I want to make sure that everyone kind of has someone to go off of and doesn't feel lost here. Keep your hands raised. Keep your hands raised. Or if they don't have a partner, they know how to do this themselves, and that's fine as well. Is everyone squared away? OK, perfect. All right, guys, I am going to introduce the workshop here. So here's the base URL, right? HTTPS resilient integration workshop.herokuapp.com. And I've got 4 endpoints here. I've got v1 register, and then you pass it username. Then I've got v1, and this is a post request. I should probably put that up. Post request for v1 excavate, and excavate returns you a bucket full of gold. Okay? And the goal here is to store as much gold as possible to your username as you can, right? And then you've got the final endpoint where you can view the totals for your user. So, just to recap, post request, post request, post request, get request, okay? Because in all of these 3 things, you're creating, in this case, a username, in this case, a bucket, in this case, a storage record, right? And then in here, you're getting information about, you know, what has been stored. So this will return stuff for you, and the first 3 are post, the last one's a get, and the goal here is to build an application that continuously excavates gold and stores it, right? There's going to be failure, and this was really fun to write, by the way, this service. This was awesome. I laughed a lot, which should give you some indication as to some of the curveballs you're going to come across. The goal is to build an app that continuously excavates gold for a registered user and never crashes. So if this works in the end, you're just going to be constantly excavating and constantly storing. All right? The bulk of this time is going to be spent, it's 3:08, we've got till 4:30. I'll probably stop it at 4:15, just so the last 15 minutes we can go through, maybe 4:10. Let's just stop at 4:10. We'll go through kind of some of, you know, your guys' implementations, talk about some of the curveballs I threw, and see if anyone got a working application. So I'm going to be walking around, making sure everyone kind of knows what's going on and is not confused with anything. Also, my associate here, Enrique, will. So that should help out. Thanks, guys. Let's get coding. Who was Super Mica team? Awesome. You guys made some headway. And Juan Ignatios L? Awesome. Great. Did I pronounce that right, or did I totally screw that up? Oh, awesome. Thanks. Yeah. Cool. Well, hey, guys, that was great. Thank you for participating in this section. This was a lot of fun to build. Mainly, some of my favorite parts were when someone would come up to me and multiple people came up and said, hey, is it supposed to do this? Is it supposed to break? And I was like, yep. And then they were like, ah. Yes, I was very evil with how I did some of these things. So What were some of the curveballs that I threw? Who's got one? An example. You have one, right? You showed it to me.
Yeah, it's HTML code that says AWS error.
Yep.
HTML, it's not JSON or...
Yep. So sometimes there'd be a failure, and it would happen randomly, and it would be HTML. And that makes no sense. What else did I do? Random timeouts. Yep. Yep. There was the 500. There was a 502. There was a 504. 0. I don't think I did a 0. Maybe I did. I don't know. That'd be good. Yep, there was some of that. So here was what I did exactly. I did 10% of requests took 6 to 60 seconds to return. 5% were random 500 failures with a non-JSON response. But the headers told you that it was JSON. And it said something like, whoops, something went wrong. We had 5% gateway error. 5% of the requests slept for 30 seconds and then gave you the HTML stuff when the gateway timeout error. 20% of the excavation requests gave you dirt instead of gold. And then totals endpoint said in the headers that it returns JSON, but it was actually just true or false. So if you treated it as JSON, your application would be like, what? So that was a really fun exercise for me. I hope it was for you guys as well. Yeah. So as a part of this exercise, you guys were tasked with coding as defensively as humanly possible, right? There were lots of things that you had hoped you could rely on, but then this broke, and then you're like, oh, God, I can't rely on that, right? My aim is that today, using what you've done here, a similar approach, right? Programming just as defensively as you were when you were integrating with this extremely volatile third-party application. You take the same approach when you integrate with any other third-party application, right? You might call that overkill, but when it breaks in production, that's when you know, Dave was right. I should have taken the time to do that, right? Now, here's the other side of the coin, right? Deadline pressure. Some people say, I don't care if it doesn't work 100% of the time. I need this thing shipped, right? That's a problem, right? And when you're building resilient, integration points, you need to make sure, you need to take a stand as a professional and say, I know I'm not going to deliver something that is of poor quality, right? If it's incorrect, I'm not going to do it. An example that Uncle Bob, Robert Martin, uses is doctors don't skip washing their hands, right? If he's got 5 surgeries in one day, and in order to cram it all in, it would be a lot easier if he skipped washing his hands. That would obviously be problematic, right? That's a surefire way to have some sort of complications. Just like if you're building if you're building a third-party integration, or you're building an integration of any sort, like a point of, high possible failures, you need to take the time. You need to, allocate X amount of time to say, hey, this time is going to be spent solidifying this and building these defensive mechanisms into the application. So, thanks.